they keep talking about the differences between our countries. But you know, we're all educators. And every single one of them in this room are here to work with children, to improve them, to help them have a better life. And I don't see a lot of differences. I've gone to a lot of conferences and a lot of places, and you can put a group of teachers anywhere, and they immediately bond. Because we all have these common denominators. We're all working with small children who either like to pull on your clothes, sometimes get sick in your room, which is most unpleasant, and they lift you up. And sometimes they break your heart. So we'll talk a little bit more about that, but let's talk about the fact, like I say, I've had all kinds of experiences in education, K through dissertation level. I actually work with master's level students now, and I serve on dissertation committees. So I've seen everything all the way up, all the way back. Now, children also need visuals. If you're going to talk about science, children need to see visuals. I've told you a little bit about it, but here's my college. Here's my first jet into Chicago, which was a wonderful 6 hours on the Etihad into the Abu Dhabi airport, which was fabulous. I could have spent more time. Another jet, and then into Lahore. Now, I've given you another frame of reference to understand where I've come from and how that relates to art and science, because we've had to use photography and give you visual images to show you how I got here. Now, one of the things that I think we should understand is that I've never understood people who say science and art don't connect. There is the most natural overlap in these two subjects of anywhere. And I believe the arts connect to everything. And if you teach what I consider the right way, everything does connect. One of the things that we do as teachers is try to show children the everyday connections in life. So let's talk about those for a minute. Science and art have a natural overlap. They're both a means of investigation. They involve ideas, theories, and hypotheses. They come together in the laboratory. You use your hands. Artists and scientists study materials, people, culture, history, religion, mythology. And they transform all of that information into something else. Now, if you go back to ancient Greece, the word for art was techne. I thought this was really interesting because it's the same word for technique and technology. And they both have the root word. And one of the things that I found as a principle that really disturbed me was the fact that teachers wanted to teach things in a certain structure. They taught music, they taught art, they taught science, they taught math, and goodness knows, don't let them overlap. And it had to be from the book, by the book, whatever was in the book. And of course, then we wanted to worry about what was on the test. Now, all of those things are important, but we all know enough at this point to know that everything that's in brain-based research has told us that children learn a lot of ways. And if you start integrating curriculum, they're going to understand it a whole lot better than if you keep it as a separate principle. Now, we know that if we separate learning, children do not tend to retain it nearly as much as when we integrate them. Now, part of the problem that I see on this is the way that science has been approached as a subject. And people look at it from the idea that these two really don't connect, but we're all born scientists, every single one of us. We all have a big brain, we all want to think a certain way, and if you get right down to it, all of us are hypothesis generators. From the time we're born to the time we die, we're constantly thinking, what if I did that, what if I do this? And seeing those connections is what science is about. Now, science, because what we've got here is a very simplified scientific method. Now, if you look at the scientific method, most people consider it a very linear progression, but it's not. If you're really working as a scientist, you're going to be bouncing back and forth on ideas. You're going to first ask a question. You're going to do research. You're going to make a prediction. You're going to test it, you're going to analyze it, you're going to report it. Well, what happens? You ask a question, you start doing some research, and you realize your question may not have been the question you wanted to ask. So you go back to that. You do a little more research, and you try to make a prediction. you start testing it and you realize the test is not really showing you what you wanted. So you have to go back to do research. And then you may even have to go back and re-ask the questions again. So science is really not any type of linear progression, but it's taught that way. We teach students this, it goes in a linear progression. But this is not really the way that science works. Now, if you compare the scientific method and the creative problem-solving model, they're very, very similar. We have our scientific method here, but let's look at the creative problem-solving model. First, you think about problems. You do fact-finding. You come up with some type of objective. You start generating ideas. You look at solution finding, and then you have to go to acceptance. So let's look at science and art from a historical perspective. And I'll start with Galileo. Galileo made these earth-shattering statements to people at the time that the world was not flat. The earth did not become the center of the universe. And what happened to him? He was put in jail. He was nearly burned at the stake. So acceptance was not part of his agenda at the time, unfortunately. So it didn't matter what he said, even though it was an absolute truth. It wasn't accepted. The same is true with creative thinking. Unless people buy into the idea and value the idea, nothing's going to happen. And if you look at the similarities in these, they're almost identical. They have different verbiage, but they're very similar. So when you do any type of scientific research, you're really doing creative problem solving as well. Now, the other part of the problem, educators, unless they are art educators, usually think of art as being fluff. That's what we do on Friday when there's nothing else left to do. Hand out a little bit of construction paper, you give the kids some crayons and pencils and say, let's make something fun. But that's not really the best way to be teaching art or to be teaching any of your other subjects. There are all kinds of ways that you can interject these. And we have to kind of change our mindset. And we have to start teaching children to think like scientists and to think like artists at the same time. And of course, my favorite example is always Leonardo. Leonardo was a great scientist, a great artist, a great engineer, and of course he had a lot of difficulty finishing some of his things because his mind was going in so many directions all the time. But he had a brilliant mind that was constantly thinking about the connections between all of these things. And here again, he didn't find a lot of acceptance. You know, he wrote his notes backwards in mirror writing so that if something happened, he wouldn't be caught because he had seen what had happened to other people. So again, acceptance wasn't part of that. Do you need me to use this? Okay. Test? Okay, I'm not much of a mic person. Usually I've got a big enough mouth that everybody can hear me. Now, we've got to start thinking about teaching the nature of science to move beyond simplistic forms of teaching. And I bet a lot of you are doing this and you just don't know it. Now, I love this anagram, art and science, and if you flip it upside down, it's philosophy. And I think that those two words go together very, very well. Let's think for a minute about what the arts teach before we decide it's just fluff and there's nothing more to it. I want to talk to you a little bit about what you can get out of teaching the arts. Well, now what are we doing there? All right. As an artist, and I am an artist as well, I paint, I make glass jewelry, I teach drawing, but I learned a lot as a teacher, trained as an artist, about the relationships that I could use in the arts in terms of teaching children. And the first thing I learned is that the arts teach us to evaluate qualitative relationships. As an artist, you are constantly thinking and critiquing what you've done. I also found that I could have lots more than one solution. And that was one of the great things about the arts, is that I could teach children to look at a problem and come up with many different
ideas and ways to actually solve a problem, instead of saying, okay, everybody draw this picture of what the plant looks like, show me all the parts of the plant, and that's it. Now, that's one way to use art, but that's not a very creative way to use art. There are a lot of other things that we could do, and I'm going to talk to you a little bit more about that. I also found that questions could have multiple answers, and that there were multiple perspectives. Our children, and I've talked a lot in this conference about global changes, and how the world is shrinking, and how we're all becoming interconnected. And teach children that they can appreciate the cultures of others, but that they shouldn't forget what makes them special from their country. And I think that's so important. And the more I visited your country, the more I've realized every culture has, and I've been to a lot of countries, but every culture has a special something about them that shouldn't be lost. And I hope that we don't do that. There's also in the arts complex forms of problem solving, and they're not fixed. One thing we know about learning is that it's in a state of flux. It changes all the time. If you think that everything is going to stay the same, you're wrong, because truth changes on a constant basis. We think we know something, and then a new scientific discovery comes up, and all of a sudden all our truths have changed again. And we also know that the arts teach us that words don't exhaust what we know. Some children are not very articulate. They can't really explain things to you well, but they can show you, or they can draw a picture. And it's not that that child isn't intelligent. That may be the way that they communicate best. And we also know that small differences can have large effects. Now, one of the things that I've seen that teachers have talked to me about a lot is that they have a hard time connecting these two things. They really feel like it should be separate. But let's talk for a minute about what you do in your classroom. When you teach, what types of things do you do with children when you're teaching them science? Anybody want to throw out some ideas?
Show them pictures, all kind of pictures.
Okay.
Yeah, and maybe they can watch a movie, because watching something and then getting the idea of something different rather than just getting
You make them
story.
do. You make them do certain
Theory,
things.
they won't be able to communicate and connect. By watching, they can communicate and connect.